MISTRAS, and I think if I understand correctly, that used to be physical acoustics a while ago. And we're going to see things related to wireless sensor nodes and acoustic emission and full feature data set extraction and the right things combined with strain monitoring. So the stage is yours, and we're curious to see what all combinations you will be showing there. We have a mic.
Hello, my name is Valerie Godinez. I'm the Director of Research and Applications from MISTRAS Group. You better know us as Physical Acoustics Operation. And I have Dr. Dita Moslin, Research Scientist for MISTRAS. And what we're going to demonstrate for you today is a wireless AE node. What we have there is a full channel of acoustic emission with a capacity to record up to 8 external parametrics. Right now what we have is we have one acoustic emission sensor right here mounted on a piece of aluminum, and we have a temperature sensor here. And these are some of the, can I have my slide please? These are some of the capabilities of the sensor. The idea is, of course, to get rid of the wires. And in order to demonstrate the operational capabilities of this system, what we have here right now is we have different columns. The first column gives you a timestamp of an acoustic emission readout. We have one channel of acoustic emission, and the data in green are the parametric data, which is temperature. Right now it's showing that we are at about 77 degrees F. And we're recording the average signal level every second, if you see. The blue data is actually acoustic emission hits that we're recording. We have Dr. also been tapping on the sensor, and we're showing the channel, the rise time of the signal, the number of counts if you're familiar with acoustic emission or traditional acoustic emission, the duration of the signal, the amplitude in acoustic emission decibels, the RMS value of the signal, and the average signal level detected. Now we have Dr. Oswin all the way outside the auditorium, and we're still receiving sensors. I think she's going to come back at some point on the other. Actually, let me show you. We can also, we're showing you actual traces of the data. On the top, we have a distribution of amplitude. On the middle, we have the temperature, and amplitude, and average signal level as a time history. And on the bottom, we have rise time versus amplitude correlation plot. And you see that all the way, during Dr. Oswin walk there, we kept receiving data as it shows here on the line display. So that's it. That's all we have to show you. I think the system speaks for itself. We demonstrate that we have the capability to detect acoustic emission wireless. With direct line of sight, we can go up to 300 feet probably. And also one of the nicest thing is that we can integrate several of these sensors into a node, a node that will have probably 4 to 6 of these sensors for local area monitor. And they all can communicate, all the processing of the data is done inside that little box, and only the results are transmitted to the base station. This system has been tested in some bridges in the New York City area, where the only problem that we have is that we needed slightly larger antennas because all the interference with all the metal in the bridge. That's it. Thank you very much.
How many channels can you have in parallel with your system?
Well, actually we have a system that, the system on the bridge had up to 12 channels of acoustic emission, but an individual node could have up to 4 channels and up to 8 external parametrics. It could be strain gauge, temperature, displacement, etc.
What's the cost roughly?
The cost is about $1,500 per channel.
$1,500 per channel. So yes. It's a little too
Still
expensive to give everybody one just as an addition.
And actually, right now, most of the cost is on the sensor itself.
Yes.
So that's what we have to drop. So we're welcome to try new sensors.
No, but $1,500 is a good, interesting price. Not just for giving away, but for some serious monitoring. Very good.
Thank you very much.